Okay, number 4. So we are now going to graph a logarithmic function. And I apologize, I should have taken these off. We're not going to do the +4 at the end, whatever that is. So go ahead and take that off because it's going to take away a little bit of the beauty of the logarithm compared to the exponential. Okay, so you need to remember that log base 2 is the inverse of 2 to the x. Okay, log base 2 is the inverse of the exponential base 2. Okay, and we know that a function and its inverse are reflected across the line y equals x, and in the end, if I graph them both together, should look like a butterfly. Okay, so when we graph the function and its inverse, they should reflect across the line y equals x, or as I say, look like a butterfly. Okay, so let's think about the function 2 to the x, y equals 2 to the x. Okay, that is exponential growth. And what does it do? It hugs the x-axis. It hugs the negative x-axis. Hugs the negative x, hugs the negative x, crosses the y, and shoots up. Okay? So what is the inverse going to do? Instead of hugging the negative x, the graph of a logarithmic function is now, notice these are going to be base with a whole number. We're not going to do base, we're not going to do base 1/2 or anything like that right now. Okay, so instead of hugging the negative x, we're going to hug the negative y, cross the x-axis, shoot to the right. Okay, do you see the butterfly? Yeah, it's symmetric across the line y equals x. So they are connected to each other. So what we're going to do is I like to make a table for the exponential and then just switch the x and the y, and that'll give us the table for the log. Okay, let's get started. So I want the inverse of log base 2 of x minus 1. So I'm going to step 1, switch the x and the y values, and now solve for y. Okay, so to solve for y, I go from log form to exponential form. Base 2, exponent x, answer is y minus 1. Okay, so we really need to know that converting from log to exponential, exponential to log. And then I'm solving for y, so I add 1. So y is equal to 2 to the x minus 1. What is that going to look like? Plus 1. Plus 1. So what is that going to look like? It's going to have an asymptote like that. So it's going to raise 1 in the positive y direction. Okay, so this is like opposite day. So what is the log graph going to do? It's going to move, instead of going positive up 1, it's going to go to the right one. Y becomes an x. Everything that was an x becomes a y. So it's going to have an asymptote here, cross the x-axis, and shoot to the right. Now, those are not great. Those are just sketches. So now we're going to make a table and see what it really looks like. So I plugged -1, 0, and 1 into y equals 2 to the x plus 1. So more accurately, -1 is 1.5, 0 is 2, and 1 is 3. Okay, that is my exponential. The inverse will be the reflection of that across the line y equals x. So since I know that it's an inverse, I'm going to make a table and I'm going to switch the x and the y values. So instead of -1, 1.5, 1.5, -1, 2, 0, and 3, 1. I just switched the individual x's and y's. So I have 1.5, -1, 2, 0, and 3, 1. So here we go. And it's going to hug, instead of hugging the y-axis, it's going to hug the x-axis, and it's going to have a vertical asymptote. So there they are. If I just sketch the line y equals x, there's the reflection and there's the butterfly. Number 5, we know it's a log graph. An exponential would follow the negative x-axis, cross the y-axis, and curve up. A log is going to follow the negative y-axis, cross the x-axis, and curve to the right. Now, there will be shifting, but that's the parent graph. So we are looking for the red one. Okay, next step. Let's make the inverse of log base 2 of x plus 5. So we want the inverse. So we switch the x and the y value, and then we solve for y. We do that by going from log form to exponential form. So base, exponent, answer. So y is equal to 2 to the x minus 5. So let's make a table. So I plugged in -1 and got -4.5. 0, -4, and 1, -3. That is the inverse function. That is the exponential. So now, since my two functions are inverses of each other, I'm going to switch the x and the y's to get the table for the log function. -4.5, -1, -4, 0, and -3, 1. -4.5, -1, 0, -4, and 1. -4.5, -1, -4, 0, -3, +1. So now we know that it hugs what used to be the y-axis. Okay, here's my parent graph. See how important it is to do the parent graph? Now, this has been shifted 5 units to the left. That's why it's no longer hugging the y-axis. But look, it's the opposite of +5. It's been shifted to the left 5, just like all the others work. Number 6, we know that if the bases are the same, then the exponents are the same. So let's look at our table of powers. Okay, so we're going to add one more column. How about anything to the 0th power? 1 to the 0th power is 1. 2 to the 0th power is 1. 3 to the 0th power is 1. 4 to the 0th power is 1. Anything to the 0th power is 1. Okay, so if the bases are the same, then the exponents are the same. So we want a common base. 4 to the 3x is equal to 4. 4 to what exponent equals 1? 4 to the 0 equals 1. If the bases are the same, then the exponents are the same. So 3x is equal to 0. Divide by 3, x equals 0. Number 7. So we see that both of the sides are a power of 6. 6 to the 2n. Okay, now we are going to use our knowledge of exponent rules. Cross the line, change the sign is equal to 6 to the negative 1. If the bases are the same, then the exponents are the same. 2n is equal to negative 1. Divide by 2, n equals negative 1/2. Number 8, 16 and 64. We need to check our table of powers. Okay, we see that 16 and 64 are both powers of 4. They're also both powers of 2, but we're going to use powers of 4. We're going to use 4 as the base. So 4 squared equals 16, and 4 cubed equals 64. So 4 squared is 16, and it has an exponent of 3m. And 4 cubed equals 64. Okay, these are superpowers, so I multiply them. 6m is equal to 3. Divide by 6. Leave the answer as a reduced fraction, 1/2. Okay, number 9. You are literally just hitting log 60, or some calculators 60 log with the calculator, and you are just going to get 1.778. Now, notice number 9, there's no base here. So this is base 10. Okay, you just use a calculator. The calculator is base 10. But what if it's not base 10? Then we have to do the change of base. Yeah, this is the base. What is this right here? This is the answer. So change of base, log of the answer divided by log of the base. So we have log of 34 divided by log of 7. Now, you will see some teachers, they don't use log base 10, they use natural log for some reason. I do not. I use log base 10. There's one of each buttons on the calculator, and I use log base 10. So change that, plug that into the calculator, and you should get 1.812. Okay, natural log. You just hit natural log 5.6, or some calculators 5.6 natural log, and you should get 1.723. Okay, if you have any questions on how to work the calculator, let me know. Number 12. Okay, so notice this is the exponential part. We need to isolate the exponential part. What am I going to do with this part? Am I adding 6? No. I am dividing both sides by -6. And I get 16 to the x minus 8 is equal to 14.166. Okay, how do you solve an exponential? We use the exponential to log conversion. The whole point of log is to solve for the exponent. Okay, so let's rewrite this. Log base 16 of the answer 14.1666666 is equal to the exponent goes over here. Okay, so now x minus 8 is equal to log of the answer divided by log of the base. So we get x minus 8 is equal to 9,56107. Add 8. X is equal to 8.956107, which rounds to 8.9561. Number 18, we need to isolate this exponential part, so we're going to subtract 2 from both sides. So we get 18 to the x plus 8.4 is equal to 84. Now, in order to solve the exponential, we convert from exponent form to log form. Now we do change of base. X plus 8.4 is equal to log of the answer divided by log of the base. Plug that into your calculator. X plus 8.4 is equal to 1.5329. Subtract 8.4. So we get x is equal to, round to the 10,000ths, negative 6.8670.